Okay, today we are looking at finding the patterns, and by finding patterns and looking at the structure of problems, we're going to come up with algebraic expressions that act kind of like a rule. That they kind of will help us finish data charts regardless of which value that might be missing, something like that. And they give us, in this case, the one we're going to be looking at, they tell us which value we're going to focus on. Here, in this chart, it has a question. It says, how many miles will Jill run on the end day? Now, that end day, it means it's like a variable for any day. How many miles will she run on the 100th day? How many miles will she run on the 50th day? And based on the data that is presented to us in our chart...
May I have your attention, please? The girls' basketball team needs to report to the Family Resource Center.
Is anybody in here? Okay, then you can go. This video, I'll post it to YouTube so you can watch it at home and hopefully it'll help you. But anyhow, based on the rule that we come up with, the algebraic expression, you can figure out how many miles she will run on any given day. First, we have to see if we can find a pattern. Now, it's very, very, very important that the pattern, before we can call it a pattern, it's observable at least 3 instances. We have to be able to look at least 3 instances to declare it a pattern. You got it? Now, let's look at this part here. Here it says day 1. Day 1, Jill, she went 0.25 of a mile. Maybe she's walking for exercise and she's starting out slow and she walks 1/4 of a mile the first day. On day 2, she has walked 5/10 of a mile, half a mile. She's walked half a mile. And on day 3, she has walked 0.75 of a mile, 3/4 of a mile. So when we look at day 1, she starts out with 0.25. Day 2, she has 5/10. Or if we want to, we could put a 0 here and say 50/100. That trailing 0 does not change the value at all, but I know since these have 2 digits to the right of the decimal point, I thought I might do that for this one. And then 0.75. Now, let's check something out. One of the things that
All
I
students who
see...
route the shuttle bus may now come to the office and load.
Alright, that's it of you all. I'm going to let you go. Now, I'm going to tell you something, little man. I'm not going to send this with you. I'm going to keep it, and you can work on it tomorrow, perhaps, when you come to your social class. Okay, back here, the connection that we have with 1, 2, and 3 is that they're ordinal numbers. You know, you got first, second, third, first day, second day, third day, or day 1, day 2, day 3. And on the first day, 0.25, and then 50/100. What do we know about 0.25, and then 0.50, and then 0.75? What do we see is going on? All right, little Wyatt.
What I see is going on is it's going up by 25 actually, because it's going from 25 to 50, and 25 plus 25 is 50, and then 50 plus 25 is 75.
Okay, so you're saying that it goes up each day by 0.25, by 0.25. Now, if that's true, and I can agree with you, then how could you quickly come up with how many miles she ran on day 20? Is it possible to figure that out? Or would we have to find out day 4, 5, 6, 7, 8, 9, 10, all the way to 20, and add 0.25 every day in order to figure that out? I mean, that's going to be very time consuming. I want to be able to do this very quickly, so any day given to me, whether it's maybe on a year later, 365 days, how many miles has she ran based on her pattern? What do you think about that? All right, Andrew.
Well, you know that if it's going up by 25 each day, that on the fourth day she's going to walk 1 mile. So on how many days it is, you can see how many times the 4 will go into it, and then you have how many whole miles she walks.
So you're saying in 4 days she goes 1 whole mile. Okay, so you could say like on 8 days, 2 miles, and so on. What about on the 27th day? That's not a multiple of 4. What can you do then? So you're looking at right now as multiples of 4. I think there's a different pattern there that we can look at. How about this? Check this out. 1 times 0.25 is 0.25, right? 2 times 0.25 is what? 0.5 or 0.50. 3 times 0.25 is what? 0.75. So it looks like, based on the pattern that I've seen, is that you simply multiply the day by 0.25. So you could say N for whatever day times 25 hundredths. But now let's talk about this. Technically we could say that, couldn't we? But now when I see I've got a variable and a constant and I'm multiplying them, I want to make that constant a coefficient with the variable. What would be what we could do? What could we do, young lady?
You could get 0.25 and you can put the variable beside of it.
So you're saying I could simply say 25 hundredths N, and that would be my algebraic expression, which would show how many miles she will run on the nth day. So if we wanted to know 27, a minute ago somebody was saying, well, you can maybe divide by 4, and that would tell you how many miles, but 27 we said was not a multiple of 4, so it wouldn't work. Let's test it. So we could say 0.25 times 27. And that would give us how many miles she ran. Now, I'm going to use my math toolkit, in this case my calculator, just to quickly solve that one. It's a little bit much for me to do mentally. So 0.25 times 27, and that would be 6 75 hundredths miles. So, by coming up with this algebraic expression, we can figure out how many miles that Jill runs on any day. On any day, can't we? As long as she continues to go up each day by 25 hundredths. Think that'll work? I think we got it. I think we got it. Let's look at another example. Let's look at number 2. It says, complete the chart by writing an expression for the pattern. Now, the directions on this item aren't as clear as I wish they were, because I've had students in my homeroom, the class I had before you all, what they wanted to do is they said 13, you go up by 5, you get 18. 18, you go up by 5, you get 23. 23, you go up by 5, you get 28, and they want to move on and say they're done. That's not what you're doing. You're not just completing the chart. What you need to do is you need to come up with an algebraic expression that helps with the pattern. And if we have S as a variable,
The following students come to the office going home: Sky Bird, Shane Dawson, Samantha Riley, Reggie Tackett, Alex Smith, Ethan and Aiden Day, Kimmy and Leland Bowman, Dylan Gay, Cadence Chandler, Cody Hensley.
we're making an assumption then that S here would be 56, because 26 goes up by 10 to 36, goes up by 10 to 46, and we're assuming S is 56. That can't work. S could be anything, okay? Now, it looks like, the pattern, if it continues on, if it holds, and going up by 10, it looks like it would, but we got to come up with an algebraic expression for our pattern. So let's look at relationships that we see with these values. How about we look at 26 and 13? How are they related? How are they related, little Morgan Bigley?
Because if you get 13 and you multiply it by 2, then that equals 26.
Yeah, and let's check it out. We got to find three instances where it holds true. What about 18 and 36? What's true about, what's the pattern there? All right, sweet little Carissa.
18 times 2 is 36.
Okay, so you can times 18 by 2 and get 36, or on the flip side, divide 36 by 2 and get 18. What about 46 and 23? What do we notice about that one, Madison?
If you double 23, you'll get 46.
And if you divide 46 by 2, you get 23. So if we want to be able to figure out S, what we might want to do is figure out what do they do to these in order to get this part. What do they do to this value to get this? What do this value to get this? And we'll do that to S, and that'll help us figure out what we're going to put here regardless of what goes here. So what are we going to do to it? Think about for a second. All right, you've had a chance to think about it. Talk to your partner. What do you think we are going to do to S to figure out what goes in that blank right there? Go ahead and figure out what goes on with this.
Alright. The thing that would go in with S is, well, let's look at that. 26 minus 13 is 13. 36 minus 18 is 24. 46 minus 33
And then it goes up like that.
What's it going up by this one? It's going up by 13. It's going up.
Taking her, yeah, going home.
It's going up by 26. 36 is 2.
Okay, you've had a chance to talk to your partners about it. What are we going to do to S in order to figure out what goes here? What do we do to S? What do we do to it? All right, I'm going to sling this one back at little Jimmy Dale.
You're supposed to make it a multiple of 28 and weeping.
Okay, I'm going to stop you right there because you're on the wrong track. We're not going to make S a multiple of 28. We're not, okay? Because this, I'm going to take this value right here and I'm going to erase it because let's say it's not 28. Let's say it's anything, it's blank. We just want to know what do we do to S in order to figure out what goes in that blank spot. All right, I'm going to go over to Ryan.
S divided by 2.
We divide it by 2. So we could say S divided by 2, and we could write that like this. Or we could say S over 2. We could actually say half S. Half S. Now, let's talk about how we can test this to work out. Let's say that we know S is equal to, well, let's continue the pattern. Let's say that S is equal to 56, let's go 66, okay? Because we already know that if this is 56, we know that this is going to be, what?
28.
It's going to be, well, 5 more from that's going to be 28, or we could say half of, or 56 divided by 2, of course, is 28. 66 divided by 2 equals what?
33.
Say it again. 33.
Jerry Larkin, come to the office, please.
And 28 plus 5 does equal 33. So I will say S divided by 2 or S over 2 could work as an algebraic expression for the pattern. Okay? Now, how do you feel fairly confident that you can do this? How many of you feel confident that you could look at the pattern and structures of these charts, such as this one here, and you can figure out how to come up with an algebraic expression? Okay. Now, I see a lot of hands up. Everybody feels pretty confident. Here's what I'm going to do. I'm actually going to take my eraser, and I'm going to erase this part right here. And the reason I'm erasing this part right here is I want to emphasize what I'm looking for when we check this work. I'm not looking to see if you've got values here and here. I'm looking for the algebraic expression. Without the algebraic expression, you are not completing the work you need to do. You got it? You got it? Okay. I'm going to let you all work for a while and see how you do.